Welcome to This Explainer. Today, we're tearing down that massive intimidation factor surrounding coding interviews, and we're giving you the ultimate blueprint. We are talking about your precise roadmap to mastering data structures and algorithms, or DSA, without losing your mind in the process. If you've ever felt completely, just overwhelmed by the sheer volume of coding problems out there, you are in exactly the right place. Okay, let's dive into this. Here is our structured path from total chaos to complete interview clarity. First, stop grinding random problems. Second, Phase 1, the foundations. Third, Phase 2, core patterns. Fourth, Phase 3, advanced concepts. And finally, number 5, the ultimate practice loop. So let's just address the elephant in the room right away. It's the big question literally every beginner asks. Do you actually need to solve 500 or more leetcode problems to get a job at a FAANG company? The answer is an emphatic no. No way. Fun fact, a ton of engineers who grind out 500-plus problems still bomb their interviews. Why? Because they optimized for memory, not logic. Today, we're completely replacing that exhausting, endless grinding myth with targeted, strategic pattern recognition.
Section 1. Stop grinding random problems.
I absolutely love this quote from our sources. Expertise is about identifying the shape of a problem, not memorizing the answer. See, top tech interviewers are not testing your memory recall. They literally do not care if you've memorized 1,000 solutions. They're testing your structural reasoning. They want to see how you adapt to new constraints and break down a prompt in real time. And honestly, this is great news. It completely frees you from the impossible burden of memorizing everything.
Think about it like this. Brute force thinking is basically like trying to memorize the entire dictionary, just in case someone asks you to spell a single word. It's exhausting. And the absolute second you see a problem you haven't memorized, you freeze. But pattern recognition, that's what the top candidates use. They identify problem shapes and map new problems to a known mental toolkit. They see the underlying matrix of the problem rather than just getting stuck on the surface details. To build that toolkit, you need a solid timeline. So here is a highly effective 12-week roadmap that organizes all that chaos. We kick things off in weeks 1 and 2 with foundational concepts. Then, weeks 3 through 5 focus on core data structures. By weeks 6 through 8, we push into advanced nonlinear structures like graphs. And finally, weeks 9 through 12 are all about optimization, advanced patterns, and crucial mock interviews. It's a completely manageable, step-by-step path to mastery.
Section 2. Phase 1. The foundations.
The absolute bedrock of those foundations is time and space complexity. Understanding how Big O works is entirely non-negotiable. Why? Because in a technical interview, the interviewer will constantly, and I mean constantly, ask you, can you do better? If you can't articulate why an O of n squared nested loop is vastly worse than an O of n log n efficient sort, you just won't be able to optimize your code. You absolutely have to be able to talk about how your algorithm scales as the data gets larger.
Now, as you build your foundational skills with arrays and strings, you'll quickly discover the sheer power of certain data structures. Hash tables, for example, they are essentially interview magic. They allow you to convert time into space in a very direct way, giving you those phenomenally fast O of 1 average time lookups. Mastering how to use hash sets and hash maps for frequency counting or, say, finding duplicates, that forms the backbone of almost all early interview rounds.
Section 3. Phase 2. Core patterns. Two of the absolute most powerful tools in this kit are the sliding window and two-pointers techniques. I want you to literally visualize this right now. Instead of writing a slow, nested loop to check every combination in an array, imagine two index markers moving gracefully across the data. You expand, contract, and move these indices based on specific conditions, effortlessly dropping a sluggish O of n squared scan down to clean linear time. It definitely requires careful control of your state, but man, once it clicks, it changes everything. Now, what's really interesting about this concept is building a mental trigger map. It basically acts like a cheat sheet for your brain. When you read a problem and see a specific trigger, like, say, find the top k elements, your brain should instantly map it to the heap technique. If it asks for a subarray with a certain condition, boom, that triggers sliding window. This approach treats algorithms less like some grueling memory test and much more like a fun solvable puzzle. And hey, while we're talking about techniques, we have to correct a massive beginner misconception. Binary search isn't just for finding a number in a sorted array. Actually, in top-tier interviews, it is far more often used to explore monotonic value spaces. This means if an answer space consistently goes from valid to invalid at a certain threshold, you can use binary search on the answer space itself to find the optimal feasibility. It is a brilliant, brilliant optimization trick.
Section 4, Phase 3, Advanced Concepts. Let's slow things down just a bit here.
When it comes to nonlinear structures like graphs and trees, you need to know exactly when to pull out breadth-first search versus depth-first search. BFS is your go-to for finding the shortest path in on-weighted graphs, usually using a queue to explore level by level. DFS, on the other hand, dives deep using recursion or a stack, making it perfect for checking if a path exists, finding cycles, or doing a topological sort. Whether a problem looks like a grid, a tree, or a complex list of dependencies, underneath it's all just about connectivity and choosing the right traversal method.
And then we arrive at dynamic programming, or DP. I know, this is where a lot of candidates stall out and panic, but let's calmly demystify it. Dynamic programming is simply solving complex problems by breaking them down into overlapping subproblems and then caching those results so you don't do the exact same work twice. It's literally like writing down the answer to a math problem on a sticky note so you don't have to recalculate it 5 minutes later. That's the whole shebang. It's just about clearly defining how one step depends on the previous steps.
Our sources highlight a really critical piece of advice here. DP is less about speed and more about clarity. Guesswork completely falls apart in dynamic programming. A solution you can't explain step by step will just collapse under the interviewer's follow-up questions. You have to slow down, define exactly what your state means, and articulate that recurrence relation clearly.
Section 5. The ultimate practice loop.
First things first, we have to cut out the bad habits. Here are the common beginner pitfalls you need to absolutely avoid in your daily study routine. Grinding random problems without any structure. Completely ignoring time and space complexity analysis. Jumping into DP and graphs way too early before you've even mastered arrays and recursion. Memorizing solutions instead of extracting the reusable patterns. And, perhaps the most fatal interview flaw of all, silent solving. If you don't practice talking out loud while you code, you will almost certainly fail the communication aspect of the real interview.
So instead of silent solving, I want you to adopt this ultimate problem-solving template. Step 1. Always restate the goal to ensure you and the interviewer are totally aligned. Step 2. State the brute force approach. Just get a baseline solution out there on the table. Step 3. Optimize using your pattern recognition, and then write your clean code. Step 4. Confidently analyze the time and space complexity. Guys, this isn't just a clever interview hack. This directly mirrors real production-level engineering thinking.
And that brilliantly illustrates the ultimate goal of our entire journey today. So I want to leave you with this final provocative thought. When your 12 weeks of focused, structured practice are complete and you finally sit down for that big interview, are you going to be frantically trying to rely on memory, or will you operate like a true systems-oriented engineer? The choice is yours. Start your structured journey today.